Hey, what's up guys, it's Jamie, and in this video we're going to be comparing SQL versus NoSQL. Alright, and this is going to be a conceptual overview of what each of those are and the differences of each, and when you might want to use one versus the other, because it's not always obvious. If you're liking the content, be sure to leave a like and subscribe, and without further ado, let's get into the content. Alright, so with SQL, what we've got is a database that's all centered around tables. Alright, so here's an example table that you might have. Let's just say that for your app you want to store the user's username, their first name, and their last name. We'll keep it that simple for now. So in your table you're going to have some different columns. It's kind of just like an Excel spreadsheet. Each header up here is going to have its own column name. So maybe the name of the first column will be like username, and maybe the second column will be called first name, and then the final column will be called last name. Okay, so you got 3 columns, and then inside of your database, when you're writing data from your front end to the back end, you'll have different entries in here, different rows. So maybe in the first row, your first user, they signs up, their username is Billy Bob. So Billy Bob goes here, and then his first name, let's say his first name is Billy, so put a B there as well and a B there as well. That's probably not very helpful. Second example, we'll say we have, let's say Tim Ferriss comes and signs up for your app. So his username would be like Tim Ferriss, first name Tim, last name Ferriss. So basically you just put the data in there like you would in an Excel spreadsheet. And the data in here can be like multiple types, like these are all just string types, so they're all just strings of characters, like Tim and Ferriss, those are just strings of characters, whereas you could also put in information about like their age, so numbers could go in there as well. Okay, and let's say that we're building like a text editor or something where each user needs to have a bunch of notes or something like that. Well, for that we're going to need another table. So I'm just going to make another table over here. So this first table over here, this is the users table, and then this other table right here, this is the notes table. And it's really important that each entry in each table has an identifier. So over here the identifier was the username, and it needs to be a unique identifier. It's called the primary key. But for the note, I don't really see anything that would really make a note uniquely identifiable, so we're just gonna have that be an ID. That'll be like the name of this column which holds the identifiers, and the ID can just be generated by the database itself. Many implementations of SQL databases provide a way to generate an ID on the back end so that when you add an entry in here, it just automatically generates an ID. So we'll say that the first one that goes in there just has an ID of 0, and then the next one will just have an ID of 1, and it'll just simply keep counting up. And then what else do we need for our text editor? We also need like the actual text. So let's say that that's an entry inside of our table. It's the text. So each note has an ID and text. And then importantly, it also needs a user, which is its owner. And this is so that users can actually retrieve their notes. So they'll need to do what's called a query, querying for all the notes where the user ID matches their user ID. So let's say that this note right here with ID 0, let's say that it belongs to Billy Bob. So this note's username is going to be B because it belongs to Billy Bob, and then the text can just be, you know, whatever text value. It's probably some large piece of text because it's the entire text for Billy's note. And then maybe over here we'll just like have the date that the note was created, and maybe that'll just automatically happen on the back end. You can configure that as well. Alright, and then let's say that note number 1 belongs to Tim Ferriss. So he just has some text in there, and the user ID is going to be T because that's what it is over here. And then it also just has a date, which is the date that it was created. And just for completeness, we'll add one more row down here, just showing you what it would look like if we had more notes than there are users. So we'll say the next one gets another ID of 2, and then this one also just has some text in here, and we'll say that this one belongs to Billy Bob because he's the astute note taker, and then it also has a date as well for when it was created. So you can see with NoSQL, all this information is very rigid. It's in tables, and all this stuff needs to be predefined and designed to work properly, scale properly. That is in stark contrast to NoSQL. So let's move on and talk about that now. Okay, so with NoSQL, if you've ever learned about JavaScript objects or JSON objects, same sort of thing, that's going to be very helpful here because NoSQL is basically exactly like that. A NoSQL database is a giant JSON object. Literally, it is just that. And so just conceptually, I'm not going to draw like all the syntax for a JSON object. That's pretty simple. I'll show an overlay here of what it kind of looks like. But basically, you've got like some root object, which is the database, and then that object sort of like references things inside of it with keys. So let's say that this reference right here is the users. So put a U there for users. And then, so this object contains references to all of the users in our database. So we'll need one for Billy Bob, and we'll need one for Tim Ferriss. So this is Billy Bob. Put a B right there for Billy Bob. And then this is Tim Ferriss. And then each of those objects contains references to more things. So Billy Bob has a username, so put that right there. This is his username. He's also got a first and a last name. We'll put those over here as well. And this is all done again with key value pairs. So like in the topmost object, there would be a key called users, and then that users object is right here. And that users object would have a key called Billy Bob, which is the username of Billy Bob. And then that Billy Bob object contains his first and last name, so that he would have a key called like first name, and then the value of that would be Billy. And then he also has a key called last name, and then the value of that would be Bob. Same thing for Tim Ferriss down here. He just has his username, which you could debatably store that in here as well, or like since the key to Tim Ferriss was just his username, you could just omit it. I'm just gonna put it here for clarity as well. So he has a first name and a last name. So you can see that NoSQL is very tree-like. And that can get kind of dangerous. I'll explain in a second, but first let's look at this second chain down here. We're going to kind of just extend this down here because I'm running out of room. We'll say this is the notes. All right, and then inside of our notes object, we'd probably just want to have the keys to each username again so that this thing would actually scale. So we'd have an object here referring to Billy Bob's notes, and then an object here referring to Tim Ferriss's notes, just so that we could request all of their notes at once. And then the actual notes would be over here. So I think Billy Bob had 2 notes because he was an astute note taker, and then Tim Ferriss just had 1 note. And then the keys to each one of these notes would just be like some identifier. We'll choose a number here, 0, 1, 2, same as it was before. And then inside each one of those notes, we would have like the text for that note. The owner is really known already. It's back here. We could store that in here as well if we wanted to, the username, and then like the date that it was created. So the second one also has that as well. Username and then the date. Running out of room. And then finally Tim Ferriss's note also has the text inside of it, as well as the username if you wanted to, and then finally the date which it was created at. So you can see that each one of these models has kind of advantages and disadvantages. One of the advantages of NoSQL is that it's kind of a bit more intuitive. Like if you wanted to request an object from the database, you just think, okay, I want to get the Billy user object with all of his information. You just go to users/Billy Bob, and then you just request that object, and boom, there you go. And then in order to request his notes, all you got to do is request notes/Billy Bob, and then you'll get all of his notes. Or if you just want a specific note, you could do notes/Billy Bob/0, then you'd get just that note. But with NoSQL, you've got to be really careful to not store your data in the wrong spot. Otherwise, you'll be in really big trouble when it comes to scaling your app. So like, if there were 1,000 notes that Billy Bob had, and then I stored the notes under user/billybob/notes, just stored it directly over here on this side. Then every time you requested the Billy Bob object, you get everything under it. So you would get the entire 1000 notes every time you just wanted to know Billy Bob's first name. So that's bad design because it doesn't scale. So like when there's a list of things, you gotta assume that the list of things is gonna grow or can grow really large if your intention is to build something which scales. So you gotta be careful. That's why I designed the notes path over here so that when you requested Billy Bob's notes, you're getting just the notes and it was distinctly separate from all the data which represents Billy Bob. Whereas in SQL, it sort of forces you to put things into different tables because it just doesn't make sense otherwise. Also, another advantage of SQL is that it has very advanced querying. So you can build like queries which return like joining several tables together, giving you like some object that there's no way you could get with NoSQL without like querying everything and like combining it all in the front end. The querying is very limited with NoSQL, whereas in SQL it's very advanced. You can say, I want to do this operation, this complex thing, and then it gives you back all the data which you want, even though it's spread across like 10 different tables. So if you're planning on doing heavy querying, I recommend SQL. Whereas if your app is kind of just more simple, NoSQL lends itself a lot better to that sort of thing, not overly complicating it. Another advantage of NoSQL is that it's great for startups, well, most startups, because the data model is so flexible. So you just sort of pretend like things exist. You like write to certain paths and then it just makes the data there. Whereas in SQL, you have to already have the tables in place, otherwise you can't read and write from those tables. So NoSQL is a lot better for like experimental things, whereas SQL is a lot better if you need like advanced querying. Also, another thing I want to mention is that if you've ever heard of Firebase, they have a database called Firestore, which scales extremely well, which is very similar to NoSQL. And what it does is you're actually able to request objects without requesting like any of their children. So like if each user also had another object in it for the notes, like I was just saying, this was like its notes collection, and then that was like what all this stuff is down here. So these are all the notes for that user, and none of this existed. Then what you can do actually is request only a segment, only like a vertical segment of the database. So like the users collection is what it's called. You just get just the users and not any of the notes that are under those users. And so that allows you to design things more intuitively, yet still allowing it to scale without like giving yourself a headache trying to design all this other stuff. So if you're looking in NoSQL, I absolutely recommend Firebase. I have no affiliation with them, but their database Firestore it's out of this world, guys. And it's like basically free. It has insane usage parameters. Alright guys, that is SQL versus NoSQL. If you like this video, be sure to leave a thumbs up and subscribe for more videos like this, and I'll see you guys in the next video.